Hi everyone, so we're going to look at Pythagoras in 3D shapes today, and I'm going to go through this example here. I would like you to picture this pink cuboid here as like a shoebox or something. Okay, so I want you to visualize something in your head, and hopefully it makes it a little bit easier to understand and follow. So the question that we're being asked is to find the length of the diagonal EX. So that is the diagonal line EX, that yellow line right through the middle. Okay, so from the top corner of the shoebox down to the bottom corner, that is what length we're trying to find. Okay, but we've only been given a few bits of information to get started. So we know that the height of the box is 5 centimeters. The width is, the height of the box is 3 centimeters, the width is 5 centimeters, and the length is 12 centimeters. Okay. Hopefully you can spot that yellow line, the one that we're trying to find, is the hypotenuse of a right angled triangle, with this light blue line along the bottom being the base, and then the height, which is 3 centimeters, and put it together and we have created a right angled triangle which sits right in the middle of that shoebox, and we are trying to find that yellow line there. Okay, but we've only been given one side of that right angled triangle. 3 centimeters is the height. We don't know this blue line along the bottom, so we need to find out what that is first. We can now create a second right angled triangle within our shoebox. So this blue line along the bottom, okay, will be the hypotenuse of a right angled triangle, with one side being 5 and the other side being 12. So that is our second right angled triangle. And we're going to use that to help us find out what this diagonal along the base of our shoebox is first. And then we're going to use that length to help us find what the yellow line is. Okay, so I'm going to draw out the triangle that I've just created at the bottom, which is a length of 12 centimeters and 5 centimeters, and we're going to work out what that diagonal is. So this diagonal X is going to be this line that's lying at the base of our cuboid, or our shoebox as we're imagining it to be. So we'll just work out using Pythagoras as you normally would, okay, which gives us 169, so X is the square root of that, which is 13 centimeters. Okay, so our first little calculation there, we've worked out that that's this light blue line is 13 centimeters. Okay, so going back to our first right angle triangle that we had, or that I asked you to imagine, we're trying to work out what this yellow line is, which is the hypotenuse, and we're going to use our base of the triangle, which is now 13, we've worked out what that is, and our height is 3. So if I draw out our second triangle, and we've got our base, which we've just worked out, which is 13 centimeters, our height is 3 centimeters, and we're trying to work out what that diagonal is. Okay, and just work out using Pythagoras as you normally would. Okay, so that is equal to 178. So X is the square root of 178, which is 13.341, and so on. Remember to write down your unrounded answer first before you round it, and let's round it to 2 decimal places. Okay, so we have now found out that our diagonal EX is 13.34 centimeters. Okay, so when you're doing Pythagoras in 3D shapes, you want to try and spot or create your right angle triangles within the 3D shape, and it might be that you need to do 2 calculations. Okay, so there's your first and your second calculation to find out all the information that you need. Okay, so we didn't have this 13 centimeters along the bottom. We had to work out what that is first, and then use that to find out the diagonal that we're being asked for.